Okay guys, welcome back. So in the last video I explained to you about combined gas laws. So in this video I'll be explaining another concept that is based on combined gas laws. So combined gas laws was derived from the Charles law and from the Boyle's law. Right? From the Charles law you got some equation. I isolated the term here. I isolated just an arbitrary term I derived in the Charles law, and then I substituted that into Boyle's law, and then so that these two laws now are combined to form that P times V by T for any gas, P times V by T for any gas is a constant. So that is from the combined gas laws. So if P by T is a constant, now I will take the same equation. So P times V by T is a constant when the number of moles is a constant, or when the number of moles is 1. I'll take it as 1. Now what actually happens when the number of moles also changes, right? So I've been deriving, as I mentioned, when the absolute temperature is constant, you can say that the product of pressure and volume for a particular gas is a constant. So that's Boyle's law. So when the pressure is constant, you can say that the ratio of volume to absolute temperature is a constant. So that's Charles law. And you can say when the number of only the mass is constant, right? For both Charles and Boyle's laws, the mass is also a constant, so the number of moles is a constant. So when only the mass is constant, when pressure, volume and absolute temperature, all those are changing, and only the mass is constant, you get this equation, V by T is a constant. Now I have been taking for the Charles law, I kept T constant. For Boyle's law, I kept P constant. For a combined gas law, I kept N constant. So for these also, N is a constant. So I have been decreasing the number of constraints, or number of things I am putting in constant. Now I eliminate N as well, so that the number of moles is also changing, or the mass of this gas is also changing. Now if PV by T is a constant, what actually happens is that when this is N equals 1 mole, only PV by T is a constant, right? So and PV by T depends on the value of N, and depends on the value of N and on the behavior or the characteristics of the gas used, right? So if PV by T is N for 1 mole, for N moles, PV by T should be proportional to N, right? So this is a very important relationship. So PV by T should be proportional to N in order to satisfy this equation. So this is for 1 mole. For N number of moles, PV by T is proportional to N. So to eliminate the proportionality, I have been using a constant. Now I have been doing this for the Boyle's law and for the Charles law. So for the Boyle's law, when the absolute temperature was constant, I took P was inversely proportional to V, so I took a constant K, and then I said P equals K times 1 upon V, and then derived the equation PV equals K. For the Charles law, when the pressure was constant, I derived that V is directly proportional to the absolute temperature, or the volume is directly proportional to the absolute temperature. So V is directly proportional to T. So to eliminate the directly proportionality, I use a constant V equals K times T, and I found V by T is a constant. So similarly, to eliminate the directly proportionality here, what I'll do is I'll multiply it by a constant and equate the both sides. So the constant I'm going to use is R. So you will know what is meant by R after finding this equation. So I'll use PV by T equals N times R. So what I'm getting here is the most important relationship. The most important relationship in gas laws, I can cross multiply here, so that PV equals nRT, right? So this is the method as to how PV equals nRT comes into play. Under gas laws. So R is a constant for any gas, regardless of its regardless of its characteristics, whether the pressure is changing, the volume is changing, the temperature is changing, or whether all of them are constant, or whether the number of moles is changing, or whether the gas is changing. For any gas at any occasion or at any physical or chemical condition, the value of R is a constant, right? So R is called the universal gas constant. So since it's constant anywhere, right, it's called the universal gas constant. So this PV equals nRT is normally used for ideal gases. You may have heard what is meant by ideal gases if you watch my videos on kinetic theory of molecules. So what is meant by an ideal gas is that for any ideal gas, the gas obeys the gas laws. For real gases, the real gases normally deviate from the gas laws. So actually, in calculations we assume that the real gases behave as ideal gases. But if you do the practicals, if you do some practicals, right, in some lab or something, you will notice, what you will notice is that the real gases, actually for real gases, you can't apply Boyle's law, Charle's law, ideal gas law like this, or any other things. So these are used by ideal gases. So this is popularly called the ideal gas law. The ideal gas law. Ideal gas law. So that is the theory of ideal gas law, and I explained to you in the previous video about the combined gas laws. So I explained to you some of the problems in Boyle's law and Charle's law. So in the next two videos I'll be explaining you about some examples in which the combined gas laws and ideal gas law comes into play. See you then.